Hello, I'm now going to tell you about graphs, and in particular the coursework that you've got to do. So here's an example of a graph. It's got these things here which are called nodes or vertices, and they've all got different values. And the things that connect the nodes are called edges. Like this. And while we're at it, we can look how we can represent this information inside a computer. So here we have a two-dimensional array, and if you think of this going 1, 2, 3, 4, 5, 6, and this going 1, 2, 3, 4, 5, 6, because we've got an edge between 1 and 1, that there's an edge between 1 and 1, we have a 1 here. Now, because there's an edge between 1 and 2, that's that one there, we have a 1 there. Now, this naught means there's no edge between 1 and 3. This naught means there's no edge between 1 and 4, etc. So what does this one here mean? This is the edge between 3 and 4. So there is an edge between 3 and 4. So that's how one way we can represent graphs. Here's a data structure for representing graphs. Now, the sort of questions that we're interested in graphs are, say, the shortest path between any two nodes. So, for example, what's the shortest path between 1 and 3? Well, if we go 1, 5, 4, 3, that's 1, 5, that's length 4, 1, 5, 4, 3. Or here's a different one, 1, 5, 2, 3. But here's a better one, a shorter one, 1, 2, 3. So the sort of problems that we'll be using graphs for is finding shortest paths. So let's look at an application of that. Here is a little bit of the London tube map. And so once again, we can think of this as a graph because we've got nodes like Notting Hill Gate, Bayswater, Lancaster Gate, Bond Street, and we've got the edges that connect some of the nodes together. So this is a much bigger graph than this one over here, but nevertheless it's a graph. And we can still ask questions like, what's the shortest path between Notting Hill Gate and Green Park? Well, we can get, this looks like the shortest path, but there are other paths. We could go this way. And so one of the problems that I want you to solve is, given any two stations on the tube map, to find the shortest path. And there are lots of different ways we can think about the shortest path. We can talk about the shortest path as the number of stations that you have to go through to get from one stop to the other, and that's more or less what we were doing here. Later on we'll talk about the distances. There might be paths which have fewer stations, but the time it takes might be longer. Another consideration that we might want to think about is how many changes we have to do. But to start off with, we just think of the shortest paths between, say, Notting Hill and Green Park is the route with the fewest number of stops between the two stations. So, in order to do this coursework, we need the information about the tube map, and luckily we've got these three. We've got this useful file here called stations, and in it's got the station ID, which is just a number. It's got the latitude and longitude, the name of the station, and some other, and what line it's on, and things like that. So here's other useful information which will help us to think of these things, to manipulate these things better. Now, a useful thing is they've got the longitude and latitude of each station. So with the longitude and latitude, that's the point on Earth exactly representing that station. And with that, we can work out the distances between stations. So again, later on in your assignment, you'll have to do something involving working out shortest distances between stations. Now, there's another useful file here called edges, and edges tells us which station connected. So it says, for example, the first one here says that there's a connection between 11 and 163, and it's on line 1. So what does that mean? So if we look at our stations thing, 11 is Baker Street, and 163 is Marylebone. So on our map here, we should be able to see that there's on the tube map, Marylebone and Baker Street are connected, and line 1 must be this one here, which is the Bakerloo line. So what we'll do in the next video is show you how to use this information to find the shortest paths in tube